Alright guys, so for our fourth topic under the core subject na dynamics of rigid bodies, we will discuss the topic na rotation. So just like what I've said last time, so yung na-discuss natin from the first three module is ano lang din, application lang din nun, yung sa rotation. Okay? So anong bago lang is yung mga variable do sa equation niya. Pero yung principle and yung application is almost the same lang din naman. Ano? So before we start, let's discuss first the discussion part. Ayan. So, under this session 4, you will get to know more about the concepts of dynamics of rigid bodies and other engineering science. And by the end of the session, you should be able to, so number 1, so to analyze the motion of a rigid body in a circular path with its center on a fixed straight line called the axis of rotation. Okay, so and number 2, so understand the kinematics characteristics of rotation, which are the following. So we have the angular displacement. So this is denoted by the symbol theta, the angular velocity, and the angular acceleration. So yung mga symbol natin sa mga variable na to is, ito nga, yung displacement natin is magiging theta siya. So ang counterpart guys nito sa rectilinear translation, ito yung distance na travel natin which is denoted by s. So kapag free fall, di y lang yan or h. Kapag kay angular velocity, so ito yung small case ng omega, o denoted by the symbol. So ito yung velocity when it comes to rectilinear translation. And kapag angular acceleration, so this is denoted by the symbol alpha. So ito yung acceleration natin. Pero for this discussion, ang rotation pala mayroon dalawang klase. So meron kang tangential acceleration and normal acceleration. Actually, this is component lang nung acceleration natin mismo. Okay? So meron tayong tangential and normal acceleration. So later on naman, discuss natin what is the difference of those two. Okay, so let's proceed with the lecture part. So, rotation about a fixed axis. So, ano ba ibig sabihin natin dito? So, kailan ba nagiging yung rotation mo is about a fixed axis? So, when a body, kunin ko lang yung highlighter natin. So, when a body rotates about a fixed axis at any point P, located in the body travels along a circular path. To study this motion, it is first necessary to discuss the angular motion of the body about the axis. So, just like on this diagram, ayan nga. So, sabi niyan, at any point P daw, so ito, maaaring dito siya. So, dito sa figure, i-denote yung P as ito. So, again, any point here, dito sa circular path niya, pwede mong i-assume yun as your point P. So, again, yung point P mo noon is traveling along a circular path. So, it's either counterclockwise yan or clockwise. Pero dito, i-apply rin natin guys yung right hand rule. So, kung mapapansin nyo, ginamitan niya ng right hand rule yan. Okay, so later on, discuss natin kung paano ba i-apply dito yung right hand rule. Pero for now, let's define what is the angular motion. So, let's read the definition. So, angular motion. So, since a point is without dimension, it cannot have angular motion. Only lines or bodies undergo angular motion. So, for example, consider the body shown in the figure, okay, and the angular motion of a radial line R. Okay, so this is our R, located within the shaded plane. So, at the instance shown, so the angular position of R is defined by the angle theta. So, yung position mo daw, ayan. Sorry. So, yung position daw ng pingyan, okay, the angular position of R is defined by the angle theta, measured from a fixed reference line to R. Okay? Ayan, so meron ang fixed reference line papunta doon sa R, and yung distance na travel niya coming from a reference axis. So, ito yung itinakbo niya, or yung inikot under a circular path. So, again, ang theta mo dito is yung displacement mo din. Okay, so, yan. Ito na, si angular displacement. So, the change in the angular position, which can be measured as a differential d theta, is called the angular displacement. Okay, so this is the rate of change of theta, and normally this is called the angular displacement. So, this vector has a magnitude of d theta. So, it's either, ito nga, this is measured in degrees. So, kaya pina-review ko sa inyo yung mga conversion. So, paaring siya ay radian, or pwede rin siya in terms of revolution. So, take note that 1 revolution is 2 pi rad, and 1 revolution also is equivalent to 360 degrees. So since motion is fixed about an axis, so ito kasi yung reference axis natin, dito natin pinapaikot yung ano, yan, yung point P niyan at a distance r. So since motion is about a fixed axis, the direction of d theta is always along the axis. So along the axis lang yan or with reference dito. So laging dyan lang din yan, okay? And usually ito is, ayun nga, measured in terms of revolution o kung na ilang beses siyang ikot doon. So pwede rin in terms of degrees or in radian. Specifically, the direction is determined by the right hand rule. Ayan. So that is the finger of the right hand, okay, are curled with the sense of the rotation. So again, yung 4 fingers mo, ito yung direction ng pag-ikot ng iyong yun nga, yung point P. So that in this case, the thumb or d theta points upward. Ayan, so pataas. Okay? So as shown by the top view of the shaded plane, both theta and d theta are counterclockwise. So kung sisilipin mo daw siya dito, so kung dito yung point of view mo, ayan. So ito yung mabubuo mong figure. Ano? Ayan. So kung saan coming from a reference line or reference axis or reference point, this one. So di ba ito yung reference axis natin? So ang takbo daw ng yung theta at saka d theta is counterclockwise. Okay? Ayan. So ba't naging counterclockwise? Again, by the right hand rule. So yung thumb mo is naka-point upward and yung direction ng iyong 4 fingers is in the direction of counterclockwise. Okay? Next, so let's define now what is the angular velocity. So the angular velocity, ito yung time rate of change in the angular position. Okay, so this is denoted by the symbol omega. Ayan. And since d theta occurs during an instant of time dt. So ito yung kanyang rate of change in displacement, yung d theta over dt. So therefore, ang units ito can be in radian per second. Or pwede rin yung isang unit na pinano ko sa inyo, yung revolution per minute or yung RPM. And so on. Okay, so pwede rin siya in terms of degrees. Okay, so let's proceed with the next page. So the vector has a magnitude which is often measured in radian per second. Ayun yan, nandito pala siya. So it is expressed here in scalar form since its direction is also along the axis of rotation. So based sa 16.4a or ito, and kapag sinilip mo sa top view, ito siya. So yung direction ng iyong displacement d theta at saka yung theta. So since counterclockwise yan, same lang din yung ikot ng acceleration, yung angular acceleration mo. Tsaka yung angular velocity na omega. Okay, so nasa tayo? When indicating the angular motion in the shaded plane, we can refer to the sense of rotation as clockwise or counterclockwise. Here, we have arbitrarily chosen counterclockwise rotation as positive. So take note of that. So we always assume that kapag counterclockwise siya, that is positive. So siguro sa moment, isipin nyo na lang kasalungan tayo ng moment, di ba? Kapag moment kasi laging clockwise yung positive. But here in the rotation topic, so yung counterclockwise yung inaano nating positive. So ano nyo na lang, right hand rule, di ba? So dapat lagi ka lang na thumbs up para positive. So kailan ba siya nagiging thumbs up? So paano yung ikot ng iyong 4 na daliri kapag na thumbs up, di ba? Counterclockwise. So ayun na lang yung isipin natin. Ano? However, that the directional sense of omega is actually outward from the page. Tama, palabas naman yan. Next, we have the angular acceleration. So this is denoted by the symbol alpha and it measures the time rate of change of the angular velocity. So the magnitude of the vector is the change in our angular velocity or yung d omega over the rate of change in time. So it is also possible to express alpha as yung d squared theta or kung maaalala nyo under sa rectilinear translation. Diba double derivative lang siya ng ds all over dt. Okay, so pwede mo rin siyang i-denote using this relationship. Okay, so the line of action of alpha is the same as that for our angular velocity omega. However, its sense of direction depends on whether omega or yung angular velocity is increasing or decreasing. Ayan. Nakabase rin pala dito kung sa pabilis ba yung angular velocity or sa pabagal. So if omega or yung velocity mo is decreasing, then alpha is called the angular deceleration. So tama naman, pareho lang din naman sa rectilinear translation. So kapag pabagal yan, So, nagkaaroon ka ng deceleration or yung value ng acceleration mo is negative. And vice versa, kapag increasing, so acceleration yung tawag doon. And therefore, has a sense of direction which is opposite to omega. So, by eliminating dt from equation 16-1 and 16-2, we obtain a relationship between the angular acceleration, angular velocity, and angular displacement, namely as this equation. So, saan nga ba nakuha to? So, di ba yan ay parang kamukha lang din ng sa rectilinear translation natin. So, knowing that yung ating velocity is the rate of change in distance over the rate of change in time, and acceleration, that is the rate of change in velocity over the rate of change in time. So, sinob lang natin siya with respect to sa dt. So, by cross multiplication, ayan. And sa kabila, di ba, over a. So, if dt is equals to dt, so ganun lang din to, So, ds all over v is equals to dv over a. So, our equation is acceleration times the change in displacement times v dv. So, kung saan, di ba, yung counterpart nga ni s is yung theta, yung alpha is yung acceleration, and yung velocity is yung angular velocity. Ayan. Okay? Kasi hindi pa to hindi talaga yung ang ibig ko lang sabihin dito, guys, is parang ito yung counterpart niya dun sa rectilinear translation. Pero hindi talaga ito yung formula niya. So, sa sunod na slide, doon yung malalaman kung paano nakukuha yung displacement s with respect to sa theta. Kasi nga, ang unit kasi nitong theta is in radian, di ba, minsan? Kung saan yung radian, ito is considered as unitless. So, nilalagyan lang siya ng radian minsan. For example, ayun nga. Katulad dito sa topic na to. Pero, kung isipin mo, wala talaga siyang unit. So, ayan, i-discuss natin dito sa mga susunod na Okay, so ito lang din naman yun. So, constant angular acceleration. So, ito yung sa topic natin na So, yung omega dito, this is the final angular velocity. So, di ba, kung maaalala, yung Vf is equals to Vo plus AT. And then S equals to VOT plus 1/2 AT squared. And yung final velocity squared is equals to initial velocity squared plus 2AS. So, ito nga rin yung pinakita ko rin sa inyo noon, di ba? Meron siya kasing initial, for example, dito, initial velocity. Ito, initial displacement. And yung initial displacement, ito dito. Pero ito, sabi ko nga, i-disregard nyo na lang din to. So, kung mapapansin nyo, kamukha lang din ito niyan. Okay, so ito yung sinasabi kong same application lang din naman, nag-iba lang yung mga variable sa equation natin. Okay, so motion of point P. So, shown in the figure, so as the rigid body in figure 16-4C rotates, ayan, point P travels along a circular path of radius r. So, umiikot siya dito at a distance of r. Okay, so ito yung P mo, and mag-a-act lang siya dito sa boundary ng circle natin. So, this path is contained within the shaded plane shown in the top view in 16-4D. Okay, so the position and displacement, the position of P is defined by the position vector r, ito nga, which extends from point O to point P. Okay, or ito yung radius. If the body rotates du, ito ay d theta, then P will displace as ds equals to r d theta. So, ibig sabihin pala, if gusto mong ma-compute yung displacement, so, yung iyong angular displacement na theta, imumultiply mo lang ng r. Okay, which is correct naman, di ba? Kasi nga, itong theta mong to, this unit is in terms of radian. Sabi ko nga, ang radian is parang unitless din siya. So, if we're going to multiply it by the radius, so for example, meter, so masasatisfy natin yung unit ng s, which is the displacement. And for the velocity of P that has a magnitude which can be found by dividing ds equals to r du by dt, so ito yon. So, kapag gusto mo namang ma-compute yung velocity mo, so yung angular velocity, imumultiply mo lang din ng radius r. Kasi nga, ang unit nito is in radian per second or unitless per second. So, kung imumultiply mo yung ibabaw ng distance r, so magiging na siya. For example, within meter, so magiging meter per second na. Okay? As shown in the figure, ayan, the direction of V is tangent to the circular path. So, tangent lang siya dito, or kapag na-extend ka ng horizontal line, ayan. So, dito lang sa point na to, ito yung point of tangency. Okay. So, ang velocity mo is always tangent daw doon sa circular path mo. So, kung nandito na yung point P, so ito yung velocity mo. Okay? So, lagi lang siyang tangent. Or ang isipin mo, tinamaan niya lang yung circular path ng isang point na ganun. So yun yung kaya nga point of tangency. Doon nag-tangent yung ano. Or kapag nag-drawing ka ng horizontal line dyan, ayan yung mangyayari. Okay? Next, for the acceleration, guys, ito na yung sinasabi ko. So again, ang iyong acceleration has two components. Meron kang normal and tangential component. So the equation for the tangential acceleration is given by this equation. So the tangential component of acceleration is equals to r multiplied by alpha, which is the angular acceleration. And to get the normal acceleration, that is equals lang sa omega squared or yung angular velocity squared multiplied by the radius r. So ano ba yung tangential component of acceleration? Ayan, so dinefine naman dito. Oops, di nag-open yung highlighter. So the tangential component of acceleration, so this represents the time rate of change in the velocity's magnitude. If the speed of p is increasing, then the tangential acceleration acts in the same direction as v. Okay, so kung maalala yung figure kanina, so, di ba yung velocity mo nga, yung v is tangent lang din do sa circular path. So, ganun din yung tangential component of acceleration. So, sabi nga, AT acts in the same direction as v. So, if the speed is decreasing, AT acts in the opposite direction. So, ano siya ha? Pabalik. Ano? Kasi nga deceleration, babagal, negative value siya. Opposite the direction of v. And finally, if the speed is constant, AT is 0. So, kung constant lang yung bilis ng velocity niya, so wala ka naman talaga tangential acceleration. So, AT is 0. Next, for the normal component, so kung yung tangential mo is tangent dun, or kumbaga para naging parallel siya do sa iyong point of tangency, yung normal force naman is papasok or ito is perpendicular. Ayan. So, kung makikita nyo dito sa figure. So, ang tangential mo again, ayan. Ito yung tangential acceleration. And kapag yung normal acceleration, so papasok siya dun sa iyong axis of rotation. Okay? So again, ito yung axis of rotation mo. Okay, so let's define what is the normal component of acceleration. So this represents the time rate of change in the velocity's direction. So the direction of AN is always toward O, or the center of the circular path, o yung axis of rotation mo. Okay, so laging papasok na dun. And kung saan niya, ang formula niya is ito. So paitandaan na lang nito. Ayan. So, I think, problem solving na. Okay? So, mas ma-appreciate nyo to. Ito naman kasi mga discussion, pinaliwanag lang dyan. Pero kung magsosolve ka, parang nag-solve ka lang din ng unang tatlong module natin. Ano? So, kaya ito is, ano lang, kumbaga pahapyaw na lang kasi ganun lang din. Kung may nadagdag man, ito lang, no? Yung pagkuha ng normal component ng acceleration. And, bago po nga pala magkalimutan, kung gusto mong kunin yung total acceleration nga, so that is just equals lang sa square root ng AT squared plus AN squared. Okay? Ayan. So, hindi pala nakasama dito. Okay, so guys, so para mas ma-appreciate nyo siya, let's try this on some examples. Okay, so let's start with problem number 1. So, basahin muna ulit natin. So, the rim of a 50 inches wheel on a brake shoe testing machine has a speed of 60 miles per hour. So, when the brake is dropped, it comes to rest after the rim has traveled a linear distance of 600 feet. So what are the constant angular acceleration and the number of revolutions the wheel makes in coming to rest? Okay, so isulat muna natin yung mga given. Again, so ang given dyan is yung rim of a 50 inches wheel. So, knowing that yung diameter ng wheel natin is 50 inches, and yung speed daw, or yung speed ng wheel is traveling at a rate of 60 miles per hour. So, this is our initial velocity. So, 60 miles per hour. So, kung mapapansin nyo, magkakaiba yung unit niya. And it comes to rest after the rim has traveled a linear distance. So, ito yung displacement natin. So, kumbaga, yung wheel na yan, so, naatakbo pa siya ng 600 feet. Okay? So, what are the constant angular acceleration? So, pinapahanap sa atin si alpha. So, walang sinabi. Pero do sa book, ang binigay is yung, or yung hinanap sa kanya, is yung tangential since, ayun nga, ang counterpart niya is yung angular velocity. And the number of revolution. So, number of revolution. So, ito yung yung theta or yung angular displacement natin. So, these are the unknowns. So, first, maganda is gawin muna natin siya na pare-parehong unit. Okay? So, if we're going to solve for r, so, di ba kalahati lang naman siya ng radius or that will be 25 inches. So, saan kaya natin siya pwedeng dalhin na unit? Siguro, since English naman to, dalhin na lang natin sa mga unit na FPS, mga feet per second squared. So, yung 25 inches, ma-convert natin siya to feet. So, 1 feet is equals to 12 inches. Ayan. Ito pala medyo maano. So, 60 miles per hour. So, we all know that in, paano nga natin convert? So, 1.609 kilometers is to 1 mile. Ito, sorry mahaba yung kabisado kong conversion. Pero meron itong hindi ko lang 5280 yata. Yun yung unang pumasok sa ko. Pero na lang natin kasi hindi rin ako sure kung ano. Pero pa-check na lang din guys if yun nga yung direct conversion niya. Pero ito yung sa ulo ko talaga. So from kilometer, so we all know that we have 1,000 meter in 1 kilometer. So medyo mahaba lang yung conversion ko So again, meron din naman to sa ALQ. So hindi ko lang yung kabisado yung mga conversion table. Pero na natin since simulan na rin naman natin. So from meter, so we have 100 cm in 1 meter. And then from cm, dadaling ko siya sa inches. 1 inches is 2.54 cm. And then 1 feet is equals to 12 inches. Ayan. So I think okay na tayo doon sa ibabaw. Check ko lang. Okay, so tama naman yung conversion natin. So, just to clarify, na-intriga lang din ako. Ano nga yung conversion? 5280 nga ba yun? So, hindi ko muna isasama yung i-check ko lang if 5280 nga. Pero ang tanda ko talaga is 5280 siya. Times 100 divided by 2.54. So, ayan nga, 5280. Pero yung atin, may mga putal since Pero anyway, hindi naman magkaalayo masyado yung niyan. Yung conversion niya. So, ito na lang yung gawin natin. So, 1 hour is to, anong sinabi ko? 3,600 seconds. Alright, so what is the equivalent value of this? So, i-times na natin ng 60. And then divided by 3,600. So that is 87.9811. 87.9811 feet per second. Right. So I think we're done. Ano nga hinahanap dito? Okay. So ang gawin natin, knowing that yung iyong velocity is equals to r omega. So kailangan natin ma-compute yung angular velocity niya. So, yung velocity, yung initial velocity, divide lang natin siya sa ng r. Just this one. Paguhin ko lang to para hindi tayo malito. Okay? And sa displacement nga, di ba, S is equals to r theta. So, to solve for theta, so that is equals lang sa S all over r. Okay? So, what will be the angular velocity? So, yung initial angular velocity natin is asaan ka? 87.9811 divided by 25 over 12. So, 25. So, tataas itong 12. Ayan. 9811.912 pala yun. Ayan. So, multiply mo lang ng 12 and then divided by 25. So, that is 42.231. So, this is in radian per second. Okay, so yung angular displacement, yung theta, so 600, so divided by r, or 600 divided by 25 times 12. So that is 288 radian. Okay, so ito palang theta, mahanap na natin siya. So, number of revolution. So, paano natin makukuha yung number of revolution? Meron na kasing theta dito Makukuha na natin siya in terms of revolution. So, ito, you just need to convert that to revolution. So, alam natin na sa isang revolution, 2 pi rad. So, 2 pi radian. So, ito is 360 degrees. Tama? Or pwedeng pi over 180. Or 180 over pi. So, cancel na to. Tapos, alam natin na in 1 revolution, there is 360 degrees. Okay? Tama ba? Tama. So, what is the equivalent value of theta in terms of revolution? So, 288 divided by 2 pi. So, that is 45. Eka, nangimay. So, that is 45.8366. Revolution. Okay, so ano pa ba yung pinapahanap? Yung angular acceleration, So ano ba sabi dyan? When the brake is dropped, it comes to rest. So again, meron dyang keyword na nag-rest. Or therefore, yung final angular velocity niya to certain time, so that will be equals to 0 radian per second. So magre-rest na siya. So again, para malaman yung angular acceleration natin, so ilatag mo muna ulit yung mga equation na pwedeng gamitin. So the final is equals to initial plus angular acceleration times the time. Yung isa, we have theta is equals to initial velocity times t plus 1/2 of at squared. And yung pangalawa, final velocity is equals to initial velocity plus 2a theta. This is alpha. Okay, so pili ka within these 3 equation kung alin yung pinakamagandang gamitin. I think itong kuli yung pinaka-applicable. Or kung gusto mo, kagaya na ginagawa natin sa rectilinear translation, combination nitong dalawa. So, hanapin mo yung t, and then once na nakuha mo yung t, substitute mo doon sa isang equation. Pero i-shortcut na natin, since ito naman, alam ko naman kayang-kaya nyo nang gawin to. So, ito na lang yung gamitin natin, guys. So, 0 squared is equals to initial na 42.231 squared. So, ito expected ko na magne-negative kasi siya magsi-zero coming from velocity. So, babagal siya. So, gawin ko na lang plus para hindi tayo malito. So, plus 2 and then angular acceleration. And then multiply by, hindi ito yung igagamitin natin kasi ito revolution Ito, yun ang radian. So, times 288 radian. So, ang sagot niya is negative. So, alpha is negative 42.231 squared over 2 times 288. So what is the angular acceleration? That is 42.231 squared divided by 2 divided by 288. So that is 3.0963. So that is in radian per second squared. Okay? So kung ipahanap sa inyo yung total acceleration, di kunin nyo yung normal angular acceleration and then just take the sum of the squared of that. Tapos i-square root nyo. Okay? So ito pala ay ano nga pala? Negative siya. Or ang pwede mong gawin, pwede natin sabihin na 3.0963 radian per second. So this is deceleration. Ayan. Okay guys, again, I'll give you 2 minutes to copy this problem and the solution. So you may start copying. Okay guys, let's proceed with the next problem. Okay guys, so let's proceed with the problem number 2. So again, basahin muna ulit natin yung problem. So when the angular velocity of a 4 feet diameter pulley is 3 radian per second, the total acceleration of a point on its rim is 30 feet per second squared. Determine the normal acceleration of the pulley at this instant. Letter B, determine the tangential acceleration of the pulley at this instant. And letter C, determine the angular acceleration of the pulley at this instant. Okay, so what is given in this problem? So given yung diameter niya na 4 feet, at the same time, yung angular velocity niya is denoted by omega na 3 radian per second. So find the following. So for letter A, yung normal acceleration. For letter B, the tangential acceleration. And for letter C, yung angular acceleration. Okay. So, unahin natin hanapin yung for letter A. So, again, ano nga yung equation natin for the normal acceleration? So, di ba ito is given by the equation na r omega squared. So, given naman yung ating angular velocity. So, knowing na yung ating r is just half of the radius, or that is 2 feet. So, mahanap natin yung kanyang normal acceleration. So, that is 2 feet all over 3 radian per second squared. Okay, so the normal acceleration, so 3 squared, 9, 18 feet per second squared. Alright, so ito pala, given pala yung total acceleration na A is 30 feet per second squared. Ayun, mahanap nga pala natin yung tangential. Dali lang pala itong let number 2. Next, for letter B, so again, knowing that yung ating acceleration is, yung total acceleration is the squared of an squared plus yung tangential squared. So to solve for the tangential, so that is equals lang sa square root ng a squared minus an squared. Okay, so square root lang natin. So that is 30 squared minus 18 squared. So what will be the answer for this? Pindutin lang natin sa LQ. So we have 30 squared minus 18 squared, and just take the square root of that. So we have 24. So 24 feet per second squared. Ayan. And then for letter C, ano ba yung hinahanap dyan? Yung angular acceleration. Okay, so to get the angular acceleration, so yung ating A sub t, diba yung A sub t natin is equals lang sa r alpha. So to solve for alpha, so that is equals lang sa 24 and then divided by r, which is 2. So yung angular acceleration natin is 12 radian per second squared. So wala namang ni-required na unit. So ito na siya. Ayan. So let's just check. Okay, so tama naman. So again guys, I'll give you again 2 minutes to copy this problem. So you may start copying. Okay, so next problem. Okay, so basahin natin yung problem number 3. So the rotation of a pulley is defined by the relation rotation theta is equals to 2t raised to 4 minus 30t squared plus 6, where theta is measured in radian and t is in seconds. So for letter A, compute the value of the angular displacement theta when the time t is equals to 4 seconds. Next, compute the value of the angular velocity at the instant t is equals to 4 seconds. And letter C, compute the value of the angular acceleration at the instant t is equals to 4 seconds. So guys, this example problem is ano ba yung niyan? Saan topic siya papatak? So di ba doon siya papatak sa na-discuss natin sa module 2 or the variable acceleration motion? So under this topic again, at anytime t hindi same yung acceleration niya. So at every specific time nagbabago yung kanyang angular acceleration. Okay, so ganun lang din naman guys yung ma-establish nating relationship dito. Again, we all know that yung iyong velocity, so that is the change in d theta all over dt. And for the angular acceleration, so that is the change in angular velocity with respect dun sa time. So again, merong 5 cases dyan, pero sabi ko nga sa inyo, yun rin naman yun. So, magbigay lang tayo ng isang example and the rest is, ano lang din naman, yun din. Same lang din sa module 2. Ang nangyari nga lang, ito nga lang yung nabago, yung mga variable natin. So, unahin natin yung letter A. Anong required sa letter A? So, the angular displacement theta if the time is equals to 4 seconds. So, ang given equation sa atin is yung theta mismo, 2t raised to 4 minus 30t squared plus 6. So, anong gagawin mo for letter A? So, tama. So, by directly substituting the value of t as 4 seconds, makukuha natin yung kanyang angular displacement. So, 2 times 4 raised to 4 minus 30 times 4 squared and then plus 6. So, again, ang unit natin dito is in radian. So, pindutin natin siya sa calculator. So, 4 raised to 4 times 2 minus 30 times 4 squared and plus 6. So, this is 38 radian. Next, for letter B, what is the required in letter B? So, compute the value of the angular velocity. So, ang angular velocity mo, again, is given by the relation na d theta over dt. So, anong gagawin natin dito sa equation na to? So, tama, we need to derivative this equation. So, by taking the derivative of this, magiging d theta and then equals, so, 8 t cube. So, factor out ko lang yung dt. Ano? So, ilabas ko na lang dito. So, minus 30t squared. Sorry. Derivative na pala ako. So, minus. So, 30 times 2, or that will be 60t. So, 2 minus 1. So, 1 na lang yan. And then plus 0 na to, kasi constant na siya. So, nung finactor out ko, transpose ko sa kabila para at least mapagmukhanan siya nating d theta over dt. So, again, yan yung iyong angular velocity. So, since meron na tayong equation na ganyan, ano bang pinapahanap at what time? So, when the time t is equals to 4 seconds, so what will be the value of our angular velocity? So, just substitute that value, 8 times 4 cube minus 60 times 4, or that is equals lang sa 8 times 4 cube and then minus 60 times 4. So that is 272 radian per second. So may binigay bang unit? So wala naman so this is acceptable na rin. Pero pag may specify na units, so kailangan nyo siyang i-convert do sa unit na yan. And for letter C, so the angular acceleration, again, angular acceleration is given by this equation. And knowing that yung equation nga natin for the angular velocity is given as at cubed minus 60t. So, anong gagawin natin dito sa equation na to? So, just take the derivative of this. Or this will be equals to dw or d omega minus is equals to a times 3, so 24 t squared. So, again, factor out ko na lang guys yung dt. So, minus 60. So, quantity of dt. So, ano mo lang yan? So, d omega over dt. Again, yan ay equals lang sa ating angular acceleration. 24 t squared minus 60. So, again, at time, ano ba yung required? So, again, 4 seconds lang siya. So, alpha is equals lang sa 24 times 4 squared minus 60. So, what is our angular acceleration at 4 seconds? 24 times 4 squared minus 60. So, we have 324. So, anong unit niya? Radian per second squared. Okay, guys. So, those are the answer for problem number 3. Again, I'll give you another 2 minutes to copy this problem. So, you may start copying. Okay, so let's proceed with the next problem. Okay, so for problem number 4, basahin natin. The angular acceleration of a pulley which will rotate from rest is increased uniformly from 0 to 12 radian per second squared during the 4 second. And then uniformly decrease to 4 radian per second during the next 3 seconds. Compute the angular velocity at the end of 7 seconds. And for letter B, compute the angular displacement at the end of 4 seconds. So guys, saan category ba ito papatak? Okay, so tama. So itong problem na to, pwede natin siyang i-analyze using the motion curve. But for this problem, ang gagamitin nating mga values or variable is with respect dun sa mga unit for rotation. So, ganun lang din naman yun. Ang mangyayari lang dito guys is yung first diagram natin is yung angular acceleration. Okay, so ano nga yung una natin ginagawa? I-plot muna natin yung acceleration diagram. So, ito yung ating alpha, which is in terms of, silipin ko lang doon sa ano, kung kita ba yung nakasulat. Ayan. So, this is in radian per second squared. And yung x natin, so that is in time, so that is in seconds. So, interpret ulit natin yung problem. Ano sabi? So, from 0 to 12 radian per second during the 4 seconds. So, from 0, increases uniformly to 12. Ayan. So, 12 radian per second. So, project ko lang to guys. So, during the 4 seconds. Okay? And then, uniformly decrease to 4 radian per second. So, coming from 12, magiging 4 siya. Ayan. So, still positive value. So, 4 radian per second squared. During the next 3 seconds. Ayan. So, ito ay 3 seconds. Okay, so next, i-plot naman natin yung kanyang angular velocity diagram. So this is in omega. So the unit of this is in radian per second. So this is the time again. So this is in seconds. So paano ba natin siya i-drawing? So again, take note of the keyword. So kasi sabi dyan, so from rest, it is increased uniformly from 0. So, nagsimula siya sa rest, ibig sabihin, yung initial velocity niya at time 0, so 0, yung kanyang angular velocity. So, ngayon, alamin natin yung magiging angular velocity niya at 4 seconds. So, just take the area of this, itong area nito, which is an area of triangle. So, minimum, maximum. Ayan. So, this is a second degree curve. So, coming from first degree. So, area ng triangle. So, ito is magiging... Saan ba ito? Teka lang. Gawin ko na lang to as omega after 4 seconds. So, to solve for omega at 4 seconds, so just take the area of this triangle again. So, 1/2 of 4 times 12. Or that is equals lang sa... 4 times 12 divided by 2. So this is equals to 24 radian per second. Ano bang hinahanap? So, angular velocity at the end of 7 seconds. So, ito. So, after that, consider natin yung area nito. So, coming from this point, so, since nasa ibabaw siya, so, i-add mo lang yung area. So, maximum, minimum. So, pag ganyan yung magiging shape natin. Ayan. So, ito pala yung required sa after 7 seconds. Okay? So, to solve for that, so, yung velocity niya dito, initial velocity, so 24, and then plus the area of this trapezoid, or that is equals to 3/2 times 12 plus 4. So, the velocity, angular velocity after 7 seconds is equals lang sa sum ng 24 plus 3/2 times 12 plus 4, 16. So, that is 48 radian per second. So, this is the answer for letter A. Ayan. So, again, wala naman sinabing unit. So, i-radian per second na lang natin. So, guys, kung walang sinabing unit, automatic dito madadalhin sa unit na to, ha? Next, for letter B. Ako, dito ko pala na isulat. Teka lang, ha? Pwede ko kayang ilaso tool to. Yun. Good. Ayan. Nice. Nice. Next. Again, nasunod dito is yung ating displacement. Angular displacement, which is in theta. So, unit of nito is in terms of radian. Okay, so guys, ang pinapahanap lang kasi dito is yung displacement after 4 seconds. Which is madali lang, no? Area lang naman itong parabolang yan. Pero kapag yung displacement niya at 7 seconds, so i-apply nyo lang din yung tinuro sa inyo. Yung example natin do sa last problem, yung medyo mahaba and apply mo ng mga formula. Okay? So, para lang din umabot tayo sa 1 hour na lecture. So, ito na lang, hanggang dito na lang. Pero alam ko naman kaya nyo nang gawin. Or, i-type nyo na lang doon sa comment section below kung ano yung kanyang equivalent na angular displacement after 7 seconds. Pero dito sa problem, 4 seconds lang yung pinahanap. So, kunin lang natin yung area. Ito. So, again, ganun lang ulit. So, minimum, maximum, magiging 3rd degree lang to. So, displacement after 4 seconds. So, that is equals lang sa 1 over n plus 1, 1/3 ng base na 4, and then height na 24. So, the answer for that is 24 times 4 divided by 3. So, that is 32 radian. Okay? So, again, hanapin nyo na lang yung at 7 seconds. So, i-comment nyo doon sa comment section below. Tapos, i-compare na lang ninyo kung pare-pareho kayo ng sagot. Okay guys, again, siguro I'll give you 1 minute to copy this one. So, gawin na natin 2 minutes. So, please copy. Okay guys, so para sa ating sunod na topic, i-discuss na natin ngayon yung curvilinear translation o mas kilala sa tinatawag na projectile motion. So doon tuturuan ko kayo ng technique. Meron kasi yung mga derived formula. So ipapakita ko sa inyo kung paano na-derive yung mga formulang yun. Pero ako, ang gawa ko, combination lang kasi yun ng guys free fall at saka rectilinear translation. So, kukunin mo lang yung mga component, tapos, ayun nga, ipaghahaluin mo lang yung dalawa. So, papakita ko yung dalawang approach using the derived formula. So, expected naman na madali kapag derived formula. Pero sabi ko nga sa inyo, if there's a way, kasi ako mahina nga sa sauluhan. So, if there's a way na pwede mong i-derive or gumamit ng ibang approach para lang hindi madagdagan yung sasauluhin, yun yung ginagawa ko. Kung analysis lang naman din yung kailangan gawin, doon ako sa mababawasan yung sasauluhin. Sabi ko nga, sa dami naman ng formula, lalo na sa subject ng mga hydraulics and geo, saan daan-daan yung formula, malaking bagay yung may mababawas ka kahit isa. Alright guys, so thank you and see you on our next video lecture.